In the autumn of 1983, the United States Army began deploying a highly specialized piece of hardware into the dense forests of West Germany. It was a solid, fueled, two-stage ballistic weapon known as the Pershing II. On paper, it was classified simply as an intermediate-range nuclear missile. In physical reality, it was a technological wedge that fundamentally broke the established mathematics of global deterrence. Prior to the arrival of the Pershing II, Soviet military planners sitting deep inside the Ministry of Defense in Moscow operated under a standard, reliable early warning window. If the United States launched a Minuteman intercontinental ballistic missile from an underground silo in North Dakota, Soviet early warning satellites watching from highly elliptical orbits would detect the infrared signature of the launch plume. A few minutes later, massive over-the-horizon radar stations scanning the polar routes would confirm the incoming warheads. This multi-layered architecture gave the Politburo and the General Staff roughly 25 to 30 minutes to assess the raw data, confirm the attack, authorize the unlock codes, and issue retaliatory launch orders. It was a tight, high-pressure window, but it allowed for a human chain of command to function. The Pershing II erased that luxury because it was stationed right on the edge of the Iron Curtain in Europe, and because its maneuverable re-entry vehicle plummeted through the upper atmosphere at 8 times the speed of sound. The flight time from a launch pad in West Germany to a 1 megaton detonation over the Kremlin was reduced to exactly 6 minutes. Before we dissect exactly how Soviet military engineers attempted to solve this terminal vulnerability, subscribe to join us as we explore these historical deep dives, uncovering the classified blueprints of the Cold War. 6 minutes. Think about what that timeline actually meant for the human beings managing the Soviet nuclear apparatus. 360 seconds. Within that brief span of time, duty officers monitoring early warning radars had to detect the launch. They had to cross-reference the data to verify that it was not a flock of geese, a solar reflection, or a hardware glitch. They had to transmit that warning up the rigid, heavily bureaucratized chain of command to the General Staff. The military leadership then had to physically locate the General Secretary of the Communist Party, brief him on the end of the world, receive his authorization, retrieve the launch codes from the mobile nuclear briefcase system, and transmit those specific codes back down through encrypted channels to thousands of missile silos scattered across 11 time zones from the Ural Mountains to the frozen tundra of Siberia. It was biologically, mechanically, and bureaucratically impossible. The human brain and the Soviet administrative state simply could not process the onset of a nuclear war that fast. Look at what the declassified military records show regarding Soviet strategic anxiety during this exact period. The General Staff became gripped by the highly logical fear of a decapitation strike. A decapitation strike is a preemptive nuclear attack designed specifically to vaporize a nation's leadership, command bunkers, and communication infrastructure before they can order a counterattack. If the Pershing II missiles targeted the primary command centers around Moscow, the Soviet Union could be functionally blinded and paralyzed before a single defensive button was ever pushed. The entire bedrock foundation of mutual assured destruction relied on the absolute, unbreakable guarantee that if you shoot at us, we will shoot back. If the central leadership is reduced to ash in 6 minutes, who possesses the legal and technical authority to give the order? If the isolated silo commanders deep in the Siberian wilderness lose radio contact with Moscow, do they fire their intercontinental ballistic missiles on their own? The entire global deterrence model breaks down completely under the weight of this uncertainty. To bridge this fatal gap, Soviet military engineers were handed an unprecedented mandate by the highest levels of the government. They needed to design an absolute safeguard. They were tasked with creating an automated command and control system that could guarantee a massive retaliatory nuclear strike, even if every political leader, general, and top-tier military commander was already dead. The project became officially known within the Defense Ministry as the Perimeter System. The Western intelligence apparatus would eventually come to call it the Dead Hand. But creating a fully automated retaliatory machine presented these engineers with an incredibly complex technical paradox. How do you build a system capable of independently launching thousands of nuclear warheads without accidentally triggering a global apocalypse because of a single faulty wire, an isolated power surge, or a rogue computer glitch? If you completely strip the human element from the nuclear launch chain, you intentionally remove the judgment, the hesitation, and the contextual awareness that had saved the world from accidental war on multiple prior occasions. You're handing the final verdict on the continuation of human civilization over to an array of copper wires, rudimentary algorithms, and early 1980s circuit boards. Stay with me here, because the engineering logic required to solve this contradiction is fascinating. The designers of the perimeter system knew that external early warning networks were notoriously unreliable. Space-based satellites could be blinded by sunlight glinting off high-altitude cloud formations. Ground-based early warning radars frequently misinterpreted anomalous weather patterns, atmospheric disturbances, or even the rising moon as incoming missile formations. If the automated safeguard system relied on looking outward, scanning the horizon for the mere threat of an incoming attack, the probability of a false positive was mathematically unacceptable. An automated logic circuit monitoring a radar screen might misread a sensor anomaly as an American first strike, automatically initiating a full-scale retaliatory launch and plunging the planet into nuclear winter for absolutely no reason. Therefore, the engineers realized the system could not look outward. It had to look inward. To entirely prevent an accidental launch based on a false alarm, the system could not react to the possibility of an attack. It had to react to the physical, undeniable reality of a completed attack. The central question defining the entire perimeter engineering project became a matter of extreme sensory verification. How could Soviet contractors design a machine capable of independently verifying the end of the world? The machine would need to physically feel the destruction of the Soviet homeland. It would require a sprawling network capable of gathering absolute proof that multiple nuclear detonations had occurred on Soviet soil, and it would need to algorithmically prove that the high command in Moscow had permanently ceased to function. Only when both of those absolute conditions were met would the system assume command. But understanding that the machine needed to verify its own destruction was only the conceptual baseline. Implementing it in the physical world was an entirely different engineering hurdle. If Moscow was a smoking crater, if the standard underground communication cables were melted into slag, and if the strategic radio towers were vaporized by thermal radiation, how does an isolated dead machine actually talk to the surviving missile silos thousands of miles away? The standard communication infrastructure would be completely useless in the aftermath of a decapitation strike. To solve the problem of transmitting the final launch codes across a totally destroyed nation, military planners had to look beyond traditional radio antennas and buried cables. The answer to their transmission problem lay in the radical repurposing of the intercontinental ballistic missiles themselves, creating a specialized mechanism that Western intelligence agencies would fundamentally misunderstand for years. When you examine the declassified engineering blueprints and Cold War intelligence assessments of the Soviet strategic rocket forces, a profound architectural revelation emerges. The backbone of the automated safeguard system was not a massive, centralized supercomputer buried deep under the Ural Mountains. A static computer complex, no matter how deeply buried or heavily shielded, is ultimately vulnerable to a concentrated barrage of Earth-penetrating warheads. Instead, the engineers opted for a highly decentralized, mobile, and almost completely unstoppable method of communication. They found their answer in a modified variant of the UR-100UR intercontinental ballistic missile. This was a heavy, liquid-fueled rocket, widely known for its brutal reliability and massive payload capacity. Under standard operational conditions, these missiles were designed to carry multiple independently targetable thermonuclear warheads on a ballistic trajectory across the North Pole. For the safeguard protocol, Soviet designers stripped away the nuclear payload entirely. The military index assigned to this specialized variant was the 15 P011 command rocket. Think about the sheer scale of this mechanical workaround. Instead of relying on a fragile web of buried copper wires and static microwave towers spread across the surface of the Earth, the military planners decided to move their entire emergency communication infrastructure into the vacuum of space. The heavy thermonuclear reentry vehicles were replaced with highly hardened, exceptionally powerful, ultra-high frequency radio transmitter pods. These command rockets were placed in specially constructed, ultra-hardened silos capable of withstanding immense atmospheric overpressure from a nearby ground burst. Their flight computers were completely reprogrammed from the ground up. If activated, these specialized missiles would not fly an offensive ballistic arc toward North American cities. Instead, they were programmed to launch on a relatively flat trajectory, flying high over the vast 11-time zone expanse of the Soviet landmass. To understand how this operated in practice, we have to look at the propulsion systems keeping these rockets ready. The UR-100UR relied on hypergolic liquid fuels. specifically a mixture of unsymmetrical dimethylhydrazine and nitrogen tetroxide. These are incredibly toxic, highly volatile chemicals that ignite instantly upon contact with each other. While dangerous to handle, they offered a massive strategic advantage. The fuels could be stored directly inside the missile tanks for years at a time, keeping the command rocket in a state of constant, permanent readiness. The moment the activation signal was received, the hypergolic propellants would mix, and the rocket could blast out of its silo in a matter of seconds. There was no need for a lengthy fueling process, while enemy warheads were raining down on the homeland. Stay with me here, because the physics of the ensuing broadcast system are brilliant in their harsh simplicity. As the command rocket climbed out of the atmosphere and entered low Earth orbit, it would effectively become an invulnerable temporary communications satellite. Streaking across the sky at thousands of miles per hour, the internal ultra-high frequency transmitters would power up. They would begin broadcasting encrypted launch authorization codes on a continuous, uninterrupted loop. The radio signal would shower down across the entire Soviet Union. Because the broadcast was originating from the upper atmosphere, it was completely immune to the geographic destruction occurring on the ground below. Mountains of radioactive rubble, melted ground cables, and destroyed radio relays simply did not matter anymore. The transmission would reach every isolated corner of the frozen empire. The receiving end of this architecture was just as highly engineered. Every standard intercontinental ballistic missile silo in the strategic rocket forces, from the heavy liquid-fueled silos in the central steppes to the mobile rail launchers hidden in the dense taiga forests, was retrofitted with a dedicated receiver network. These receivers were bolted directly into the structural concrete and tied to specialized radio antennas designed to pop up from the silo lid in the event of a sudden attack. Many of these exterior antennas were flush-mounted, meaning they were built completely flat against the hardened steel of the silo door to ensure they survived the initial atmospheric shockwave of a nearby strike. The exact moment the command rocket flew overhead and the ultra-high frequency signal washed over the silo field, the buried receivers would catch the encrypted transmission. Look at what the declassified records show regarding the internal bypass mechanisms. This is where the human element is surgically removed from the equation. Under standard operating procedures, launching an intercontinental ballistic missile requires strict human verification. Deep underground in a Launch Control Center 2, duty officers would receive a coded voice transmission from Moscow. They would write down the code, authenticate it against a sealed manual, insert their separate launch keys into 2 different consoles, and turn them simultaneously within a strict 2-second window. It is an intentional administrative bottleneck designed specifically to prevent a single rogue officer from starting a war. The 15P011 command rocket signal bypassed every single step of that human chain. The encrypted radio broadcast fed directly into the automated ignition circuitry of the combat missiles. It electronically simulated the turning of the keys. The massive steel silo doors would blow open automatically. The primary rocket engines would ignite, and the main combat arsenal would launch, all without a single living soul in the underground bunker pushing a button. To ensure this critical transmission could not be jammed or interrupted by the extreme electromagnetic environment of a global exchange, Soviet contractors had to harden the electronic components inside the transmitter pods. An atmospheric nuclear detonation releases a massive electromagnetic pulse capable of overloading and frying delicate solid-state electronics across thousands of square miles. If the command rockets lost their internal circuitry the moment they breached the atmosphere, the entire deterrent system would fail instantly. To counter this invisible threat, engineers utilized older, slightly heavier, but incredibly resilient vacuum tube technology for the primary signal amplifiers. Vacuum tubes are inherently resistant to electromagnetic radiation surges. It was a classic example of Soviet design philosophy. The technology may have been heavy and physically rudimentary compared to Western microchips, but it was absolutely guaranteed to function in the harshest possible environment imaginable. The rockets would fly, and they would scream their final orders into the void, regardless of the radiation storms raging around them. Western intelligence agencies spent years trying to unravel this specific capability, utilizing advanced satellite imagery and fragmented signals. Intelligence intercepts, they tracked the extensive testing of these unusual rockets. They monitored the raw telemetry data as the 15P011 prototypes flew across the test ranges in Kazakhstan and impacted near the Kamchatka Peninsula. But they fundamentally misread the architecture of the system. American intelligence analysts initially believed these specialized rockets were simply emergency communication relays. They assumed the highly encrypted broadcasts were meant to carry voice channels or text data, allowing surviving political leaders to talk to their isolated military commanders. They completely missed the reality that the rockets were not carrying human communication at all. They were carrying automated ignition commands. The rockets themselves were the supreme high command. The physical broadcasting mechanism completely solved the transmission problem. The Soviet Union now possessed a proven, tested method for delivering launch codes to thousands of isolated missile silos simultaneously, even if the entire terrestrial communication grid was reduced to ash. By repurposing their own heavy intercontinental ballistic missiles into temporary broadcast satellites, the engineers had successfully built the central nervous system of an absolute deterrent. But constructing a secure physical network is only one half of the equation. Having a fleet of command rockets sitting deep underground, fueled and ready to broadcast a massive retaliatory launch order, immediately forced military planners to confront an unprecedented operational hurdle. You still have to launch the command rockets themselves. The physical hardware bypass was flawless, but it led directly to the central, unyielding contradiction of the entire project. If the foundational premise of the safeguard system relies on the assumption that the general staff in Moscow has been vaporized, who or what actually possesses the authority to turn the key on the 15P011 missiles? If human leadership is completely absent from the command chain, what specific combination of inputs dictates that it is time to retaliate? The trigger mechanism could not be arbitrary, and it could not be based on a flawed estimation of a threat. Handing the authority to initiate a global exchange over to a machine required an absolute, mathematically perfect logic gate. The system needed specific sensory data that could never be generated by a flock of birds, an isolated earthquake, or a basic computer error. What specific algorithmic logic would be required to definitively prove that a nuclear strike had already occurred? How could the machine independently verify the total collapse of its own civilization without relying on a single living human commander? To solve the unprecedented operational hurdle of knowing exactly when to launch the command rockets without human authorization, Soviet military engineers had to construct an entirely new kind of sensory apparatus. The physical hardware bypass was flawless, but handing the authority to initiate a global nuclear exchange over to an unfeeling machine required an absolute, mathematically perfect logic gate. The system needed specific sensory data that could never be generated by a flock of migrating geese, an isolated geological event, or a rudimentary computer error. What specific algorithmic logic would be required to definitively prove that a nuclear strike had already occurred? How could a localized network of early 1980s computer banks independently verify the total collapse of its own civilization? Look at what the granular operational details from post-Soviet defectors and declassified military archives reveal about this specific mechanism. To answer the question of absolute verification, engineers designed a sprawling, highly redundant, and entirely passive sensor network spread across the vast geography of the Soviet Union. This network did not look up at the sky to track the thermal plumes of incoming missiles. Instead, it was designed to physically feel the destruction of the Earth around it. The machine was given 4 distinct sensory inputs to monitor. The first was light. Specialized photometric sensors were mounted on hardened communication towers and buried deep within concrete reinforced bunkers. These instruments were calibrated to detect the blinding, instantaneous flashes of intense thermal energy that characterize a thermonuclear detonation. But a flash of light alone means nothing to an automated safeguard system. Lightning strikes, meteorites, and industrial explosions all produce brilliant optical anomalies. Therefore, the photometric data had to be immediately corroborated by a second, far more specific input. The second sense was radiation. Across the Eurasian landmass, military contractors installed heavily shielded dosimeters and atmospheric radiation monitors. These sensors continuously measured the baseline of normal background radiation. They were waiting for a sudden massive influx of gamma rays and neutrons. More importantly, these sensors were hardened against and actively searching for the sudden electromagnetic pulses that wash over a landscape when a warhead detonates in the upper atmosphere. A localized spike in radiation could theoretically be caused by a leak at a civilian nuclear power plant, but a massive surge in gamma radiation combined with an extreme electromagnetic pulse strongly indicated a weaponized detonation. Stay with me here. because the engineering logic becomes even more rigorous. Light and radiation were still not enough to hand over the launch codes. The machine required physical, undeniable proof of impact. The third sensory input was atmospheric overpressure. When a heavy nuclear weapon detonates, it superheats the surrounding air, creating a massive wall of compressed atmospheric pressure that pushes outward at supersonic speeds. This shock wave crushes buildings, snaps concrete pillars, and physically flattens the landscape. To measure this, Soviet engineers deployed thousands of hardened barometric sensors. These were not standard weather station barometers. They were heavily armored devices tuned to ignore severe weather fronts, violent storms, or extreme drops in Siberian temperatures. They were designed to register only the instantaneous, massive spike in atmospheric density caused by a passing shock wave. The fourth and final sense was the most deeply buried and critical input of all. Seismometers were drilled deep into the granite bedrock of the Soviet landmass. These underground listening posts monitored the constant tectonic shifting of the Earth. But differentiating a natural earthquake from a nuclear strike required highly advanced geological calibration. Natural earthquakes build up slowly along fault lines and release energy in a specific pattern, producing a distinct ratio of primary compressional waves to secondary shear waves. A nuclear surface burst behaves entirely differently. It is an instantaneous, violently artificial point source release of energy. It creates a distinct seismic profile heavily weighted toward outward compressional waves. The algorithm processing these seismometers had to read this exact ratio to prevent a natural fault line slip in the Kamchatka Peninsula from inadvertently starting a retaliatory war. Think about what it took to combine these four disparate inputs into a single, unyielding logic gate. The algorithm operating the safeguard system was a masterpiece of cold, calculating paranoia. A single sensor trip was entirely ignored. If a seismometer detected a massive shock, but there was no corresponding flash of light, radiation spike, or overpressure wave, the system simply logged an earthquake and remained dormant. The computer brain required an escalating sequence of deadly corroboration. If it registered light, it immediately checked for radiation. If it found radiation, it waited milliseconds for the crushing wave of barometric overpressure. If the overpressure wave arrived, it verified the artificial seismic shock wave moving through the bedrock below. Only when all four sensory conditions were met simultaneously across multiple, geographically separated nodes did the logic gate move to its final, definitive test. The machine would reach out to its masters. The automated system would send heavily encrypted, low-frequency radio bursts and dedicated landline pings directly to the general staff in Moscow and the primary early warning hubs. It was physically measuring the impedance on the buried copper wires to see if the command lines were still structurally intact. If a human commander responded to the ping, or if the communication lines were still open, the machine remained strictly in a monitoring state. It assumed the human chain of command was still alive and capable of making its own decisions. But if the ping was met with total silence, if the copper lines registered as physically melted or severed, and if the four primary sensors confirmed multiple impacts on Soviet soil, the logic gate closed. The system concluded that the state had fallen. Here's where the official history fractures, leading to competing historical assessments that still divide military analysts today. The true level of autonomy granted to this unyielding logic gate remains fiercely debated. Some declassified records and defector testimonies suggest that this sprawling sensor network fed directly into a purely automated circuit. In this fully autonomous scenario, once the algorithm verified the strikes and confirmed the silence from Moscow, it electronically bypassed all human intervention and instantly initiated the launch sequence for the command rockets. The machine itself turned the key. However, a conflicting body of evidence insists that Soviet military doctrine would never allow a purely automated firing chain, no matter how dire the circumstances. Other historians and military archives indicate that a skeleton crew of highly isolated human operators was always retained as the ultimate failsafe. According to these assessments, the massive sensory network did not plug directly into the ignition circuits of the command rockets. Instead, it fed down into deeply buried, ultra-hardened spherical command posts. Inside these subterranean capsules sat a small team of duty officers. Under normal conditions, these officers had absolutely no authority to launch anything. They were completely locked out of the command system. But if the automated sensors verified an attack, and the communication lines to Moscow were severed, the logic gate would unlock the consoles in these deep bunkers. The machine would provide the surviving officers with the absolute proof of their nation's destruction, effectively transferring the launch authority to them. The system would present the data, but a human hand still had to turn the final keys to launch the broadcast rockets. As the technical specifics of the system come into focus, an escalating narrative tension arises regarding its vulnerability to spoofing or mechanical malfunction. The system was designed to be mathematically perfect, but hardware is inherently flawed. Wires degrade, sensors age, calibration drifts over time. What happens if a series of localized, highly unfortunate events trick the algorithm? Consider the sheer geographic vastness and industrial complexity of the Soviet Union. What if a catastrophic leak at a civilian nuclear power plant saturates the localized radiation sensors, while simultaneously a natural tectonic shift in the region trips the seismometers? What if, at that exact same moment, an accidental explosion at a conventional munitions plant triggers the barometric overpressure monitors and a massive solar flare disrupts the communication lines to Moscow? Could this highly specific chain of coincidences fool the logic gate into believing a decapitation strike had just occurred? If the system was fully autonomous, an isolated industrial accident combined with a geological anomaly could theoretically trick the dead hand into initiating a retaliatory launch against the West, sparking a global exchange out of pure mechanical confusion. To manage this profound operational risk, the system could not simply exist as a theoretical algorithm. It had to be anchored into physical reality, tested and tethered to heavily guarded, deeply buried command posts, capable of riding out the end of the world. In 1985, the massive sensory network and the specialized command rockets were quietly brought online. The entire apparatus was routed deep underground into a series of highly classified structures known as the Grot bunkers. These were not standard military basements. They were spherical command posts, suspended entirely on giant pneumatic shock absorbers designed explicitly to survive the direct, localized ground burst of a heavy megaton weapon. Western intelligence agencies, relying heavily on satellite telemetry and fragmented signals intelligence, watched these bunkers being built. They tracked the testing of the new rockets and the laying of the deep cables, yet they completely missed the true nature of the operation. Believing the command rockets were simply standard communication relays, the West remained blissfully unaware that an automated retaliation protocol had just been armed. But as the decade progressed and the Cold War began to rapidly thaw, the operational status of these deeply buried, highly secretive bunkers raised an alarming new specter. A threat was emerging that no early warning radar could track, and no algorithmic logic gate was programmed to survive. What exactly would happen to the ultimate automated safeguard system when the empire it was designed to protect simply ceased to exist? By the spring of 1985, the massive sensory apparatus and the fleet of specialized command rockets were quietly brought online. The theoretical algorithms, the localized sensor calibration tests, and the scattered test flights were finally fused into a single operational entity. But to physically anchor this heavily automated architecture, Soviet military planners needed an absolute sanctuary. The sprawling web of light detectors, radiation monitors, overpressure barometers, and deep bedrock seismometers had to feed their raw data somewhere. That data needed to flow into a secure physical space where the unyielding logic gate would process the end of the world, and where isolated duty officers could monitor the deeply buried hardware. Standard underground military installations, constructed with thick concrete walls and heavy steel blast doors, were entirely insufficient for this highly specific task. A standard command bunker, no matter how thickly reinforced, would crack, buckle, and collapse under the immense geological shear force generated by a direct megaton ground burst. To solve this, Soviet engineers constructed a series of highly classified subterranean structures officially designated in the military archives as the Grot bunkers. Think about the physical reality and the extreme engineering of these structures. They were not designed like standard rectangular basements or sprawling subterranean office complexes. The Grot command posts were perfectly spherical metal capsules buried incredibly deep beneath the earth. A sphere is mathematically the most resilient shape for evenly distributing external crushing pressure. But the engineers went much further than simply pouring concrete into a round hole. The interior spherical capsule was not directly attached to the surrounding bedrock. Instead, it was suspended entirely inside a massive outer cavern using a complex web of giant pneumatic shock absorbers and heavy steel suspension springs. If an American Earth-penetrating warhead detonated directly above the facility, The resulting seismic shock wave would violently thrash the outer cavern. The massive shock absorbers would rapidly compress and expand, allowing the inner spherical capsule to rock and bounce independently of the collapsing rock walls around it. The duty officers sitting inside would be thrown violently against their harnesses, the internal lighting grid would undoubtedly flicker, and the heavy air scrubbers would scream under the mechanical strain, but the physical integrity of the primary command consoles would survive completely intact. This was the final absolute redoubt of the Soviet nuclear apparatus. From inside, these suspended steel bubbles, sealed behind layers of hardened steel and completely isolated from the outside world, the duty crews waited in absolute silence, monitoring the raw data trickling down from the surface. While Soviet construction battalions were pouring thousands of tons of concrete and calibrating heavy suspension springs deep underground, the Western intelligence apparatus was actively watching from above. Look at what the declassified analytical reports from the Central Intelligence Agency and the National Reconnaissance Office reveal about this specific period. Throughout the 1980s, American reconnaissance satellites operating in low Earth orbit continually photographed the construction of new silo fields. Simultaneously, highly specialized listening posts intercepted the fragmented telemetry data bleeding off the command rocket prototypes during their test flights over the vast Kazakh steppes. Telemetry is the raw, unencrypted data broadcast by a missile during flight back to engineers on the ground, indicating engine performance, fuel consumption, and staging times. By capturing this data, the West knew that the Soviet strategic rocket forces were deploying a new, highly encrypted, ultra-high-frequency broadcast system. They knew that specialized variants of heavy liquid-fueled intercontinental ballistic missiles were being placed into heavily fortified silos. But here is where the immense capability of satellite photography and raw signals intelligence completely failed to capture the truth. American intelligence analysts fundamentally misunderstood the architecture they were looking at. When they analyzed the intercepts and the overhead imagery, they drew a highly logical, yet entirely incorrect conclusion. They believed the new command rockets were simply standard, heavy-duty communication relays. In the event of a severe conflict that destroyed traditional buried cables, Western analysts assumed these rockets would launch into low Earth orbit purely to provide a secure voice channel, allowing surviving political leaders to transmit verbal orders or text messages to their isolated military commanders. The American intelligence community completely missed the reality of the logic gate. Because the sensory network was entirely passive and deeply integrated into standard weather and geological monitoring stations, Western analysts never realized the sensors were directly tied to an automated ignition sequence. They remained entirely unaware that the system was not meant to carry human voices at all. They did not know that the command rockets were the supreme high command, programmed to bypass all human authorization and electronically simulate the turning of the launch keys in thousands of combat silos simultaneously. For years, the Western world operated under the assumption that they were facing a standard human-controlled nuclear apparatus, completely blind to the fact that an automated retaliation protocol had already been fully armed in the dark. As the 1980s drew to a close, the geopolitical landscape that had birthed this vast, uncompromising machine began to rapidly transform. A new leadership took control of the Kremlin in Moscow, instituting sweeping political reforms and opening unprecedented diplomatic channels with the West. The strict mathematical paranoia of the early decade slowly gave way to historic arms reduction treaties. The United States and the Soviet Union mutually agreed to dismantle and pull thousands of intermediate-range missiles, including the highly controversial Pershing II rockets, out of the European theater. The 6-minute decapitation window that had originally terrified the Soviet General Staff into authorizing the automated safeguard protocol was officially closed. The threat of an instantaneous, unannounced strike against Moscow receded drastically. Stay with me here, because this creates a profound mechanical contradiction. The political climate was rapidly thawing, and the leaders of the two global superpowers were publicly shaking hands and declaring an end to the ideological standoff. But beneath the thawing snow of the Siberian taiga, the deep bedrock seismometers were still active. The photometric sensors mounted on hardened towers were still quietly searching the horizon for the brilliant, instantaneous flash of a thermonuclear detonation. Inside the suspended spherical grot bunkers, duty officers were still cycling through their incredibly isolated high-stress shifts, filtering recycled air and monitoring the communication cables tied to the general staff. The automated safeguard system had no capacity to understand diplomacy, international treaties, or shifting political reform. It was a machine built strictly for a singular, catastrophic purpose, and it remained fully operational, silently running its complex escalation algorithms every single second of the day. Then, the ultimate operational crisis arrived. It was a threat that no early warning radar was designed to track, and no algorithmic logic gate was ever programmed to survive. In the winter of 1991, the Soviet Union collapsed. The state did not fall to a massive barrage of incoming ballistic missiles or blinding flash of thermal radiation. It fractured under the immense weight of its own internal political and economic contradictions. Within a matter of months, the central authority in Moscow dissolved completely. A vast empire spanning 11 time zones officially ceased to exist, rapidly splintering into 15 separate independent republics. Think about what this meant for the physical reality of the military hardware spread across that massive landmass. The borderlines on the map were redrawn overnight. Suddenly, critical early warning radar stations found themselves located in newly independent sovereign foreign nations that were rapidly distancing themselves from Moscow. Heavily armed intercontinental ballistic missile silos, including many of those retrofitted with the dedicated ultra-high frequency receiver antennas designed to catch the command rocket broadcasts, were now physically sitting in the newly independent republics of Ukraine, Belarus, and Kazakhstan. The sprawling, highly integrated central nervous system of the strategic rocket forces was suddenly fractured across newly formed international borders. The logistics of maintaining a massive defensive apparatus are incredibly complex and heavily reliant on an endless stream of state funding. Hardware requires constant attention. Copper wires rust in the damp soil. Seismometers require constant, highly specialized calibration to prevent false readings caused by shifting bedrock. The hypergolic liquid fuels sitting inside the massive steel tanks of the command rockets are incredibly corrosive and slowly eat away at the internal plumbing of the missile if they are not heavily monitored and periodically flushed. As the newly formed Russian Federation plunged into a decade of severe economic depression, massive hyperinflation, and administrative chaos, the military budget was slashed to the bone. Standard infantry units went completely unpaid for months. Surface ships rusted at their moorings. The national electrical grid became highly unstable, forcing deep subterranean bunkers to periodically rely on internal diesel generators just to keep the lights on and the computer banks running. Yet, deep underground, isolated from the economic collapse occurring on the surface, the ultimate automated safeguard system remained physically in place. The collapse of the central government raised an alarming, deeply unsettling specter for defense analysts who slowly began to piece together the true, automated nature of the program through fragmented leaks and defector testimonies. If the state itself dissolves, who exactly is paying the maintenance crews to keep the optical sensors clean? Who is closely monitoring the logic gate to ensure a decaying copper wire does not artificially simulate a severed command line? More importantly, if the central political leadership in Moscow temporarily ceases to function during a chaotic transition of power, does the unyielding logic gate interpret that bureaucratic silence as a successful decapitation strike? A chilling unknown descended over the intelligence community as they finally realized what was buried beneath the former Soviet landscape. What exactly happens to a fully automated Doomsday machine when its creator quietly dies, leaving the physical hardware armed and waiting in the dark? The intelligence vacuum, following the collapse of the central government, left Western defense analysts scrambling to understand the exact status of the deeply buried hardware. For years, the operational mechanics of the unyielding logic gate remained hidden behind the chaotic administrative transition of the newly formed Russian Federation. The breakthrough did not come from a captured hard drive, a high-altitude reconnaissance photograph, or intercepted radio transmission. It came directly from the testimony of a man who spent his entire career building and managing the foundational architecture of the command and control network. His name was Valery Yarnich. He was a highly decorated colonel in the Soviet Strategic Rocket Forces who had served inside the main communications directorate for over 30 years. In the early 1990s, Yarnich stepped out of the shadows and began to speak with Western military historians, bringing the actual, unvarnished operational doctrine of the automated safeguard into the light. Look at what the declassified testimonies and subsequent military records reveal about the true nature of the machine. Yarnich shattered the pervasive myth that an unthinking, fully autonomous Doomsday device was quietly running 24 hours a day. waiting to accidentally plunge the world into a nuclear winter over faulty wire. He definitively resolved the core narrative mystery dividing intelligence analysts. The perimeter system was highly automated, but it was not fully autonomous. It was a semi-autonomous architecture. The entire sprawling network of optical sensors, radiation detectors, barometric overpressure monitors, and deep bedrock seismometers possessed an overarching manual safeguard. Under normal everyday peacetime conditions, the automated logic gate was entirely dormant. It was not actively searching for the end of the world. The deep underground grot bunkers were manned by rotating crews of duty officers, but their primary firing consoles were physically disconnected from the ignition circuitry of the 15P011 command rockets. To bring the system online, the central political and military leadership in Moscow had to intentionally activate it. Stay with me here, because understanding this specific operational flow reveals a masterpiece of strategic military engineering. In the event of a severe, rapidly escalating diplomatic crisis, or upon receiving credible intelligence that a preemptive strike was being prepared by the West, the General Staff would elevate the nuclear readiness level. As part of that highly structured escalation protocol, a designated senior officer in Moscow would turn a physical key and transmit a highly encrypted low-frequency electronic pulse down the buried copper cables. This manual transmission armed the perimeter system. The moment that pulse reached the subterranean spherical bunkers, the hardware changed state. The unyielding logic gate powered up. The massive array of physical sensors spread across 11 time zones began actively streaming raw data into the computer banks. Inside the suspended steel capsules, the launch consoles illuminating the dark space signaled to the isolated duty officers that they were now the final authority. Once the system was armed, the General Staff essentially placed the fate of the nation into a mathematical holding pattern. Think about what this specific decision meant for the human beings managing the crisis on the surface. If the diplomatic standoff cooled, or if the early warning radars confirmed a false alarm, the leadership could simply transmit a stand-down order, power down the logic gate, and return the safeguard system to its dormant peacetime state. But if the crisis resulted in an actual decapitation strike, the armed system was ready to execute its absolute function. If the leadership in Moscow was vaporized, the logic gate would recognize the sudden permanent silence on the communication cables. Simultaneously, the sensors would mathematically confirm the arrival of thermal radiation, overpressure, and artificial seismic shock waves across the homeland. At that precise second, the automated algorithm would collate the absolute proof of destruction and electronically unlock the firing mechanisms on the consoles inside the grot bunkers. The machine did not bypass the human element entirely. Instead, it presented the irrefutable data to the surviving duty officers. The human operators, sealed behind thick steel and completely isolated from the radioactive fires burning on the surface, were required to push the final button to launch the heavy command rockets into the upper atmosphere. By designing the system this way, Soviet engineers successfully solved the ultimate historical paradox of guaranteed deterrence. The semi-autonomous architecture completely mitigated the risk of a false positive during peacetime. An isolated earthquake, a localized power plant accident, or an accidental conventional explosion could never trigger a global exchange because the firing circuits were manually disarmed. Yet, the system absolutely guaranteed retaliation during a war. By requiring human leadership to turn it on during a crisis, and by handing final execution authority to a deeply buried, ultra-hardened human crew, the architecture bypassed the vulnerability of a 6-minute decapitation strike while strictly maintaining a human chain of verification. The machine was never built to independently decide to end the world. It was engineered strictly to ensure that a human decision could not be erased by a sudden attack. As the chaotic economic depression of the 1990s gave way to a stabilized Russian Federation in the early 2000 series, the new government did not scrap the physical hardware. The military budget slowly returned, and the strategic rocket forces began a massive, quiet modernization campaign. Declassified intelligence assessments and open-source defense analysis indicate that the physical infrastructure of the automated safeguard was deeply integrated into the modern nuclear apparatus. The heavy liquid-fueled 15P011 command rockets were eventually aged out of the arsenal. Storing hypergolic liquid fuels in steel tanks for decades requires immense logistical maintenance to prevent highly toxic corrosive leaks. To eliminate this weakness, military engineers replaced the older platforms with highly advanced solid-fueled variants, likely based on the modern TOPOL or YARS intercontinental ballistic missile airframes. Solid-state propellants do not degrade the internal plumbing of a rocket. They can sit silently in a hardened concrete silo for 15 to 20 years with virtually zero maintenance, remaining perfectly ready to launch in a matter of seconds. The vacuum tube transmitters were heavily upgraded with modern, digitally hardened ultra-high frequency broadcasting pods, capable of punching through extreme electromagnetic interference with greater range and clarity. While the exact operational status of the modern system remains one of the most fiercely debated topics among contemporary defense analysts, high-ranking officials occasionally drop oblique, highly calculated hints regarding its physical readiness. In the winter of 2011, the commander of the Russian Strategic Missile Forces publicly stated to a national defense journal that the perimeter system was completely intact, continually upgraded, and actively standing on combat duty. The exact digital parameters of the modern algorithmic logic gate remain highly classified, but the foundational mathematics of deterrence have not fundamentally changed. If anything, the geopolitical reality of the modern era has validated the original paranoia of the Cold War engineers. The 6-minute warning window created by the intermediate range missiles of the 1980s has been entirely eclipsed by 21st century technology. The rapid deployment of hypersonic glide vehicles, capable of maneuvering through the upper atmosphere at unimaginable speeds while actively dodging early warning radar nets, has drastically reduced the reaction time available to human leadership. Advanced stealth bombers, deeply integrated cyber warfare capabilities designed to blind command and control networks, and precision-guided Earth-penetrating munitions present an even greater threat to central command structures today than they did 40 years ago. The fundamental strategic requirement for an unyielding, heavily automated retaliatory safeguard is arguably stronger now than it was when the deep bedrock seismometers were first installed. This leaves a profound, chilling unknown hanging over the vast geography of the Eurasian landmass. The empire that originally commissioned the massive engineering project dissolved decades ago, but the physical reality of the hardware remains deeply anchored into the bedrock. Deep beneath the dark soil of the Ural Mountains, heavily modified, solid-fueled command rockets sit in ultra-hardened silos, their flight computers permanently programmed to fly horizontally across their own country rather than offensively toward an enemy. Specialized optical sensors mounted on high ground continue to process the ambient light of the horizon. Heavily shielded radiation dosimeters and barometric pressure gauges quietly read the atmospheric baseline of the modern world. Somewhere, isolated in suspended steel capsules, duty officers still sit at illuminated consoles, managing the heavily encrypted cables tying them to the Capitol. The ultimate automated safeguard remains exactly where it was placed, maintaining its silent mathematical vigil, waiting for a dawn it was engineered to guarantee, but hopes never arrives.